Welcome! This week we're going to talk about matter and energy in an ecosystem. Now, over the last couple weeks, you've learned about ecosystems and how they're a related group of organisms that all exist in the same space. You also learned about food webs and food chains. Food chains are when you show which organism eats which other organism, and food webs are when we show that there's more than one food chain in an ecosystem. But this week, we're going to really dig into what's happening when organisms eat other organisms. And so we're going to discuss matter and energy in an ecosystem. So first, let's talk about the difference between matter and energy. So I'm going to use blue throughout this presentation when I'm talking about matter, and I'm going to use yellow when I'm talking about energy. So let's start up here with matter. Matter is the stuff that everything is made of. So take a second and just look around you. If you can touch it, if it's taken up space, it's matter because matter has mass. Remember, we measure mass by how much something weighs, but that really represents how much stuff it's made of. So if it has mass and it takes up space, like when I blow air into a balloon, the balloon gets bigger because that air is made of matter. It's taking up space inside the balloon. So if it has mass and it takes up space, then it is matter. You can think of matter like stuff. I circled stuff a lot of times. So matter is like real stuff. Sometimes matter is soft or not real, like hard to feel, like air. If you move your hand back and forth, you can feel the wind you create when you move that, or if I blow it like into a Ziploc bag, I can trap that matter. And even though it's transparent and I can't see it, I know it's matter because it has mass, I can weigh it, and it takes up space. The other thing we're going to be talking about this week is energy. And energy is different than matter. Energy doesn't have mass, and energy doesn't take up space. When I talk about energy, I'm talking about the power to move, grow, make heat, or reproduce. So we're going to expand our idea of energy later in the school year. And you're probably also tapping into your understanding of energy from fourth grade when you talked about different forms of energy. Right now, I'm talking about the energy in our ecosystem. So these are the things that I'm focusing on. If you're trying to ask yourself, is there energy here? You always ask, is it moving? That's your kinetic energy from last year. Is something growing? Because to grow, it takes energy. Is something giving off heat? It takes energy to make heat. Or is something reproducing? Now, reproducing means making copies of itself. So those bean seeds that we planted earlier, the bean plant grew and it made the seeds, and we can plant those seeds to make a new bean plant. The bean plant reproduces by making seeds. Our consumers reproduce by having babies. They lay eggs or they give birth to live young. And our mold, we learned, reproduced by sending out spores. So if something is moving, growing, giving off heat, or reproducing, it is using energy. We're going to keep reviewing this every day because these are like those big fifth grade concepts, but I want you to kind of have this background knowledge as we go into our ecosystem. We're going to be talking about how matter and energy move around our ecosystems. So today we're going to focus on matter. Matter, if I'll help you remember, matter is the stuff that everything's made of. We know we're working with matter if we have something that has mass and takes up space. So let's look at what that matter looks like in our different food chains. So first I'm going to start with the producers, and we're looking at matter as it relates to producers. Producers take in carbon dioxide. You'll remember carbon dioxide is a gas when you breathe in. And we learned that plants have stomata on the underside of their leaves to take in carbon dioxide. So they're taking that into their leaves. We also learned that plants are taking in water through their roots and it travels up their trunks. We also learned that plants take in nutrients through the soil. It's not going to let me draw. Plants are taking in nutrients from the soil and carrying it up. Now, we learned when we were talking about General Sherman that plants mostly are getting their matter from carbon dioxide. So I made this one really big. I'm going to circle it. Most of plants' matter, the stuff they're made of, their mass, is from the carbon dioxide they're taking in through their stomata, but they're also taking in some water and a little bit of nutrients. So if plants are taking all that matter in, what matter are they giving off? Well, we know they're giving off oxygen because we need to breathe that. So they bring the carbon dioxide in through their stomata and then they're letting it out through their stomata. The other thing plants do is they're storing that matter in their bodies, right? They're taking the carbon dioxide from the air and using it to make their tissues or their parts of themselves. And all of that becomes food for animals. So as the plant grows, it stores the matter it has taken from the air and hangs onto it inside the plant. Next, let's look at consumers. So what matter are consumers taking in? Well, they're breathing in that oxygen that the plant's giving off. They're also taking in water. Sometimes they drink water, or sometimes just the plants they eat have lots of water in them. And then they're also taking in a lot of matter by eating foods. So this elephant here is eating plants, but some consumers eat plants and animals, and some only eat animals. So consumers are taking in matter, they're getting the stuff to build themselves from the oxygen in the air and by eating food and water. What matter are they getting rid of? Well, they give off carbon dioxide. When we breathe out, we let carbon dioxide out. They're also pooping. When they're done eating something, they're giving off waste. So that's a type of matter they're giving off. They get eaten by other producers. So maybe not as many grown elephants, but baby elephants sometimes get eaten. And a lot of other consumers become prey to predator consumers. They get eaten. And all consumers eventually will die. And when they die, their bodies are matter that gets left behind for other organisms. So the organisms that were third in our food chain are the decomposers. And I've got three pictures here because we have mushrooms and mold, which are a type of fungi. And then this down here is a super zoomed in picture of bacteria. So these are all different kinds of decomposers. And decomposers are like us in that they also take in oxygen. Their food that they're taking in is the waste that animals leave behind. So like when animals poop, decomposers break that down. But they also break down dead plants and animals. So here there's a dead squirrel and he's laying on a pile of pine needles. All of those are dead materials that these decomposers are going to break down. Then the decomposers give off carbon dioxide just like we do. So they're really not plants. They're not taking in, they're not growing with sun energy, and they're not taking in carbon dioxide. They're like us, they're giving off carbon dioxide. They also are leaving behind something that they don't use. We call it nutrients. But nutrients are like really simplified materials, things like phosphorus, which is an element, nitrogen, which is an element, and they also leave behind other minerals in the soil like calcium and magnesium and iron. So they leave behind these materials because they're breaking everything down until there's really nothing left. So what does that look like in a food web? Well, if I start by looking at my producer, I know my producer is giving carbon dioxide and is making food for other animals, and it's also giving off dead material. So sometimes the plants will die and that goes right to the decomposers. Most of the time though, the plant is going to get eaten by our consumers right here. And I'm going to draw a big circle around all my consumers. This food web shows multiple consumers, but my plants are going to get mostly eaten by consumers and they're going to give off carbon dioxide. And then if I look here at my consumers, I've got the grasshopper and the bluebird and the snake and the owl. They are giving off oxygen and they are giving off waste, which will go straight to the decomposers. But most of the time, they get eaten by other consumers. So my grasshopper will get eaten by the bluebird could get eaten by the snake could get eaten by the owl. It's also possible that they would die and get eaten by the decomposers, but we also know they're all going to poop, and their poop gets eaten by decomposers. Finally, we get to this guy. He's called the apex predator, meaning nothing else is eating him while he's alive. He's the top of the food chain, but eventually, even he will die, and his body will get consumed by the decomposers. Are you seeing the cycle? It starts at the grass with my producer, and it goes to my consumers. It goes through all the consumers, and now it's going to the decomposers. And we know the decomposers are going to give off oxygen and leave behind those nutrients, which the plant will then take in. So I'm going to draw my arrow there. So it's like a big circle. The matter just keeps getting moved around, and they all kind of share matter because the grass is going to take in oxygen from the consumers, and then the grass is going to give off, or the grass is going to take in carbon dioxide and then give off more oxygen. So you can see everything is just kind of constantly moving around. Everybody's breathing in and out and taking stuff in and giving stuff off. All of the living and moving organisms, like the consumers, are giving off waste. And eventually, everything dies and something else eats what it leaves behind. This is called a closed system. Nothing is leaving, nothing is getting used up. It just keeps getting moved around and around. That's our big idea for today. We were talking about matter. Matter just keeps getting moved around. I'll see you tomorrow when we talk about energy.